Moving into the large intestines now, since we finished the basic structurality of the small intestines. The large intestines are going to have three unique features we haven't seen yet in the GI tract. First up is this teniae coli. Now, the teniae coli are going to be three parallel bands of smooth muscle running longitudinally along the entire tract of the large intestines. We're going to have the haustra. Now, the haustra are going to be kind of like out pockets. And I'll show you a picture of this in a second. Could be out pockets created by the actual musculature of the large intestines. So because the musculature contracts, it causes the ends outsides to kind of bulge a little bit, create these pockets. Which also means the haustra actually aren't really visible on someone that is deceased. So if someone's doing like an autopsy, for example, you wouldn't see that because the musculature relaxes and the haustra simply stretch out. So an interesting fact there is the entire GI tract after death gets longer because of relaxation. So these haustra are only visible when someone is alive. The epiploic appendages, these are little kind of like almost look like fat droplets. They're meant to be storage of some lipids along the entire pathway. So let's take a look at these three specialized features plus the main structures of the large intestines. So first off, what you're seeing here, this is going to be your transverse mesocolon up top. The transverse mesocolon is going to be a membrane that helps to hold the transverse colon in place. We'll get to what that is in a second. So first off, those three structures. Haustra. Each segment is a haustra. So each one of these segments refers to as haustra. You have the epiploic appendages. Those are these things that look like little droplets. Those are little bits of lipids that are attached on there. And then you have the teniae coli. That's this line I'm tracing. That line are three parallel bands of smooth muscle that are running the entire length of the entire large intestines. So now beyond those three unique structures, we have to get into what is the large intestines. What are the parts and pieces? First off, remember the appendix. We talked about that back in the lymphatic chapter. This is the appendix. It sticks off just off the very base or the beginning of the large intestines. You have the ileocecal valve and the cecum. This right here is where you have the ileocecal valve. It's where the end of the small intestines, the ileum, goes into the beginning of the large intestines. The cecum is just this pouch that kind of starts things off, the very beginning of the whole process. From that cecum, we go up the ascending colon. So it's heading up towards the diaphragm. We then hit a curvature called the right colic flexure, or also known as the hepatic flexure. That's just this turn right here. Hepatic because liver, hepatic. From there, we're going across. That is the transverse colon. From there, we now have another turn. That turn is the left colic flexure, also known as the splenic flexure. Splenic because that's where the spleen is found. We're going to head down the descending colon. Then we get down into the sigmoid colon, kind of this curve down here is a sigmoid colon. From the sigmoid colon, we're going to head down into the rectum, storing our waste before it's removed, and then the anal canal. You can see on the outside these rings here going around. Those are the external anal sphincter. So it's basically controlling that opening, keeping it closed unless you're trying to go through defecation. Now looking at some membranes for a second. Some of these we've seen. The greater omentum, we've already talked about with the stomach. The greater omentum came off the greater curvature of the stomach. But what's new is this transverse mesocolon. The transverse mesocolon is really trying to anchor and keep that transverse colon in place while also allowing for a place for blood vessels and nerves to travel. We then have this mesentery, which that is going into the small intestines. We've already mentioned that's how it connects blood vessels and nerves there. But then we have the sigmoid mesocolon. The sigmoid mesocolon helps to anchor the sigmoid colon and also allows for blood vessels and nerves to run there. So all these different connective tissues, all these different membranes are coming together to keep the system in place, but also allow for connectivity. Here's just a different way of looking at it. We've gone through a mid-sagittal cut here. Again, a lot of these we've talked about. We've talked about the lesser omentum already, between the liver and the lesser curvature. We've talked about now the transverse mesocolon. It's just anchoring the transverse colon back to the posterior wall you see there. We've mentioned the mesentery, that's all this in purple here, helping to keep the small intestines in place. We've also talked about the greater omentum, just this flap that kind of goes over the anterior surface of the intestines, coming off the greater curvature of the stomach. Now this visceral peritoneum and parietal peritoneum, we've mentioned both those earlier in this chapter, as well as back in AP1 in that very first chapter about membranes. Remember, the parietal peritoneum is lining the outside of the entire cavity, while the visceral peritoneum is tight to every single organ. It's basically like saran wrap around all the organs. That's creating that double membrane system, reducing friction. Because as you move, as you bend, those organs can slide around. When segmentation is occurring, when peristalsis is occurring, those organs are moving. You want to reduce as much friction as possible. All right, moving down past the sigmoid colon into the rectum and the anus. This is the end of the alimentary canal. Now, the rectum actually has 3 valves set into it. These valves are meant to help separate gas from solid. Because the bacteria that are found in your large intestines, basically they're producing gas as a waste or a byproduct. That cannot simply stay within your system, so a lot of times it has to exit the system. But when it's exiting, a lot of times it doesn't really be conducive to have that exiting with solid material. So the fecal material is kept behind by these 3 different valves. Then from the rectum, you go into the anal canal itself. Now the anal canal is the very last segment of the large intestines. So we went from ascending, transverse, descending colon, sigmoid colon, rectum, and now finally the anal canal. The anal canal is going to be controlled and basically rung around by 2 different sphincters. We have an internal anal sphincter and an external anal sphincter. The internal anal sphincter is smooth muscle, while the external anal sphincter is going to be skeletal muscle. Now that's important because the internal anal sphincter, the smooth muscle, is involuntary control, while the external anal sphincter, which is the skeletal muscle, is voluntary control. So it's a conjunction of doing both involuntary processes for defecation plus the voluntary control mechanism as well. So looking at the image here, you can see the one valve up top a little bit, just to get an idea. Moving down the anal canal, you're going to come down towards the very end, which is where you find the external anal sphincter, which should be going around the entire anal canal. And then you have the internal anal sphincter, which is more inside, again, going around the anal canal. That then is controlling the defecation process. So moving through the large intestines and then finishing off through with the anal canal and the end.